All right, guys. So the video had cut short, so I have to pick up from here. So like I was saying, these are the star trails. In the center right here, you have Polaris. All right, so right here's Polaris. Oops, didn't mean to do that. You have Star Trail 1, 2, 3, 4, 5, 6. Now, what we look at is the number of degrees that the stars move. So if I look over here, I have 30. Over here, I have 90. All right, so that's a difference of 60 degrees going from here to here. If I look at Star Trail 5 and I go here, and this is 120, and I come to here, that's 180, that's a difference of 60 degrees. Even if I look at Star Trail 2, which looks really small, but I start at 270, I go to 330, it's still a difference of 60. It doesn't matter what star trail I actually pick because they're all 60 degrees in movement from where the star started to move to where it ended. All right, so what we're going to do here is we know the Earth rotates at 15 degrees per hour, so that's its rate. So we take our rate of change formula, and since we know the rate, we know how many degrees it's moved, we can figure out the time. All right, so for the formula that we could use is just going to be the change in value, meaning the change in the number of degrees, divided by 15. So in this case, I know that the Earth was rotating for 4 hours, all right, because it went from 60 degrees. So 15 divided by, 60 divided by 15 is 4. All right, so what you're going to do is taking what I just talked about and taking the number of degrees moved, dividing by 15, we can figure out how long the Earth was rotating for. So you're going to take that information, go to page 11 and 12 in your note packet. Okay, once you're in your note packet, you're going to answer those 2 pages. I'll go over the answers with you tomorrow. All right, when you guys are done with that, you're going to come back to this video and we're going to pick up on page 14. All right, so right now you can just pause this. You're going to do page 11 and 12, and then you're also going to go to your review book, and on page 62, you're going to answer questions 1 to 6. Okay, so that's what you're going to do. Note packet page 11, 12, review book page 62, questions 1 to 6. All right, then you can come back here and you can watch the rest of the video. See you later. All right, so evidence that the Earth revolves. So remember, revolve means to go around another object. So one of the key things here is that constellations change with the seasons. All right, so in your review book, it should be page 67, all right, where you see the picture that I'm about to show you, okay? So it looks like this, all right? Remember, revolution is daily changes. Excuse me, I didn't mean to say that. Rotation is a daily change. Revolution is a yearly change. So when we think about the seasons, that happens over the course of a year. Well, let's see what happens here. So here's the sun. Here's the Earth in its orbit around the sun this way. And remember, we only see stars at nighttime when they're visible to us because the sun's not out. So at the nighttime side, let's say we're facing here. These would be the stars that would be visible to us in the night sky. So they have the month that the constellation is visible. All right, so let's say in August. I know that these are a little off because we know the constellations are like half of one month, half to another, but this image does the picture from the review book. All right, so let's say if you're a Virgo, your birthday probably is like mid to late July into early middle of August, I believe. So during that time, we could see Virgo because here's the nighttime side of Earth. This is what faces the nighttime side. 6 months later, if you go into February, I could no longer see Virgo because here Earth is in its orbit. But when I try to look this direction, the sun is in the way. So I would never be able to see this. All right, so the fact that these constellations change over the course of the year indicates that the Earth is revolving. However, if they ask a question, it says, oh, what caused the constellation Pisces to move over the course of one night. Well, since it's talking about night, meaning rising and setting, then it would be rotation. But over the course of a year, these are going to appear to change simply because as Earth is revolving, we see different parts of the sky. So, for example, if my Earth is right here, facing Sagittarius, Capricorn, Scorpio, like in this area, this is when I would be able to see them. I can't see them at any other point because they would be out of my view, all right, and partly too because the sun's in the way. All right, so evidence Earth revolves, change of constellations. The next one, we're going to talk about seasons later, but obviously because of the seasons, we're going to have are caused because of revolution and the fact that Earth is on a tilt. Since the Earth is on the tilt and we revolve, it changes the amount of insolation. So insolation means incoming solar radiation. So how much energy are we actually getting from the sun? All right. Remember, we are closer to the sun in the wintertime and we are farther in the from the sun in the summer, and that's because of that tilt, and as we revolve, it's going to change that energy. So I know people always want to say, when we're closer to the sun, it has to be summer, but that's not true. It's just that in the winter, when we are at our closest points, all right, we're actually tilting away from the sun, so it's going to make our sun rays weaker. We do a whole unit on seasons. And this part's just review as well. We know that we orbit in an ellipse, all right? We know it's nearly circular, but since it is an ellipse, therefore we are closer at one point and farther at another. And so the apparent diameter of the sun changes, all right? So we did this with the moon. We talked about apparent diameter when we did Kepler's laws. And the closer we are to the sun, the larger it's going to appear. And the farther away we are from the sun, that's not supposed to say larger, it's supposed to say smaller. Oh, I got to go back and change that. Copy and paste. Don't copy that. Put smaller right here. Smaller, 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 smaller. Okay? Closer is larger, farther is smaller. All right. And since the Earth's revolution around the sun is nearly circular, it is actually an ellipse. Its rate of revolution is, this is where I would have asked you to give me the information, and it is 1 degree per day. Okay? So we did this in the notes again, like I said, I believe, what was it, page 10? Let me go look at your note packet. Oh, page 9. All right. So on page 9, we talked about the rate because it's about 360 degrees over the course of 365 days. All right. So when we round it up, we just get 1 degree per day. All right. So you are going to go to note packet page 15. You're going to complete page 15. And then after note packet page 15, I want you to read review book page 65 to 68, complete questions 20 to 27. All right, guys, and I'll see you tomorrow. Bye. Oops, I'll try to find where that thing went. Here it is somewhere. Oh, there it is.